In this question, we determine the derivative of p with respect to the lowercase r, where the lowercase r is a variable and the uppercase r and v are constant. So we have to determine this dp over dr. So first, I'm going to rewrite this given expression p, and this equals v squared r, and then times of 1 plus r 1 divided by r plus r quantity squared. So now we will focus on this expression. So when we use the power rule, that is 1 over a squared, this can be written as a raised to the power of minus 2. So similarly, we can write down this expression, that is 1 over r plus r quantity squared. This can be written as r plus r quantity power minus 2, that is raised to the power of minus 2. So this is basically the expression p. Now we will find the derivative by differentiating both sides with respect to the lowercase r. So when we differentiate p with respect to the lowercase r, we will get dp over dr, and this equals, as we know that v and r are constant, so we apply the constant multiple rule. When we do that, these two will remain as it is because they are constant, and we just have to differentiate only this term, that is the capital R plus r power minus 2. So here we can apply the power rule. So when we apply the power rule, the power will come in front. So I'm going to put the power negative 2, and then times of this expression, that is r plus r. This raise it to the power of minus 2 and minus 1. So we can simplify this. So therefore this equals, I'm going to write this as minus 2 v squared r, and then this is equivalent to r plus r raised to the power of minus 2 minus 1 is minus 3. In fact, now we can rewrite this expression once again using the exponent laws, that is a raised to the power of minus m, and this equals 1 over a raised to the power of positive m. So when we apply this exponent law, we can rewrite this expression as negative 2 v squared r, and this over r plus r quantity power 3. So this is the final expression for the derivative of p with respect to the lowercase r. We now determine the derivative of this function f of x equals x minus 6 times of x minus 3 times of x plus 2. So here we can apply the product rule. So this is basically the product rule, that is when we have product of two different functions, f of x and g of x, and its derivative is given by f prime of x, which is the derivative of f of x, times g of x, plus f of x times g prime of x, which is the derivative of g of x. We cannot apply this product rule as it is, since we have three terms here. So we can consider these two products as one function. Let's say this is g of x, and the remaining term as another function, that is h of x. In fact, we can consider any two products as one of as g of x, and the remaining as h of x. So let's consider like this. And so we have to find this derivative, that is we have to find the derivative of g of x times of h of x. So first, let's write down this in the using this formula. And when we use this formula, we have to first write down the derivative of the first function, which is the g prime of x times h of x. We then put plus the first function we write down as it is, that is g of x times the derivative of the second, which is h prime of x. So this will be the derivative of f of x. So let's find out this g prime of x as well as h prime of x, so that we can substitute into this formula. So first, I'm going to write down g of x. This equals x minus 6 times of x minus 3. And here we can apply the product rule to find its derivative. So I'm going to find the derivative, that is g prime of x, and this equals, we can consider this as first and this is second. So first we find the derivative of the first. The derivative of the first, which is x minus 6, its derivative is 1. Then multiply with the second term as it is. We then put plus. Now we put the first term as it is, and then multiply with this derivative of second term. The derivative of second term, which is x minus 3, is 1. Now we can simplify this. That is g prime of x. This equals x minus 3 plus x minus 6. So we have 2x minus 9. So this is basically the derivative of g of x. Now let's find the derivative of h of x. So first I write down h of x, and this equals, we have considered x plus 2 as h of x. So this is x plus 2. So this implies we can find its derivative. Therefore, h prime of x, and this equals derivative of x plus 2 is 1, because the derivative of x is 1 and the derivative of constant 2 is 0. So it's basically 1. So we have found out g prime of x, that is the derivative of g of x, and also the derivative of h of x, that is h prime of x. This means we can substitute into this formula. So therefore we are going to get f prime of x, which is basically the derivative of g of x times of h of x, and this equals g prime of x. We have to put g prime of x first. So I'm going to replace g prime of x as 2x minus 9. So therefore this is 2x minus 9 times of h of x. The h of x is x plus 2. So I put x plus 2 here. We then put plus, let's go back to the formula, then multiply g of x with h prime of x. So I'm going to replace g of x as it is here, which is x minus 6 times of x minus 3. And then this has to be multiplied with h prime of x. H prime of x, the derivative of h of x is 1. So we can simplify this. I'm going to distribute the terms, or we can FOIL it out. So 2x times of x is 2x squared. 2x times of 2 is 4x. Negative 9 times of x is negative 9x. Negative 9 times of 2 is negative 18. Here also you will FOIL. X times of x is x squared. X times of negative 3 is negative 3x. Negative 6 times of x is negative 6x. Negative 6, negative 3 is positive 18. So we know how to collect the like terms. We have this 2x squared and x squared, which is 3x squared. We then have 4x minus 9x, which is minus 5x. We then have minus 3x minus 6x, which is minus 9x. So minus 5x minus 9x is minus 14x. Then we have to add the constant term. So here we have negative 18 and positive 18. So these two cancels out each other. So this is the derivative of f of x. In fact, we can write down this in factor form by factoring out x. So therefore this becomes x times of 3x minus 14. Therefore we write the derivative of f of x, which is f prime of x, and this equals x times of 3x minus 14, and this is the derivative of f of x. Let's do this question. So here we are given that h of x equals f of x times g of x, and we have to determine these values, h prime of 1, h prime of 2, and h prime of 3, using this h of x as well as the graphs given for f of x and g of x. So first I'm going to write down h prime of x, which is basically the derivative of this function h of x. So here I can apply the product rule, since we have a product of two functions, f of x and g of x. So its derivative will be f prime of x, That is, we find the derivative of f of x first, multiply with g of x, we then put plus, and then put the first function as it is, that is f of x, times of derivative of the second function, that is g prime of x. Now using this, we can determine h prime of 1 by replacing x by 1. So this becomes h prime of 1 equals f prime of 1 times of g of 1 plus f of 1 times of g prime of 1. And we can determine these values, f prime of 1, g of 1, f of 1, and g prime of 1, from the graph. F prime of 1 is basically the slope of the function f of x at x equal to 1. So at x equal to 1, we have to determine the slope of this line. So for this, I'm going to use the rise over run concept. So let me start from here and end, maybe I can end over here because this seems to be a definite value. So the rise is 1 and 2, and run is 1. So it is 2 over 1, which is 2. So therefore, f prime of 1, which is the slope of the function f of x at x equal to 1, this is 2, times of g of 1 is the value of the function at x equal to 1. So we have to look at the blue line, and this seems like approximately this point, which is, we can write on this as 2.3 plus f of 1. F of 1 is also 2 times of g prime of 1 is the derivative of the g of x function at x equal to 1. So for that, we can use the slope of the function g of x, that is the slope of this line. So once again, we can use the rise over run concept. I'm going to consider this point as well as this point. So we have to come down like 1, 2, 3. So it is negative 3. This is the rise, and the run is 1, 2, 3, and 4. So it is negative 3 over 4, which is the slope of the blue line, that is the slope of the g of x. So I write down negative 3 over 4 here. We will simplify this. 2 times of 2.3, and this equals 4.6. We can cancel this 4 with the 2, and this becomes minus of 3 by 2. This is 4.6 minus 3 by 2 is 1.5. So this is approximately 4.6 minus 1.5 is 3.1. Therefore, we write h prime of 1. This is approximately 3.1. We now determine h prime of 2. So we can replace x by 2 in this expression, that is in h prime of x. So therefore, this equals f prime of 2 times of g of 2 plus f of 2 times of g prime of 2. Now we will find f prime of 2, that is the slope of the function f of x at x equal to 2. This is x equal to 2. Clearly, we can see that the slope is undefined at this point because we have a sharp turn over here. Usually, this whenever the graph having sharp turn or curves like that, we say that its derivative is 0 or the slope is 0. So this we can write down this as dne, that is it is does not exist, because if you add this with another some quantity, this is once again going to be complete does not exist. So we say that h prime of 2 does not exist. We now determine h prime of 3. So we can replace x by 3 in this h prime of x. So therefore this becomes h prime of 3 equals f prime of 3, which is the derivative of f of x at x equal to 3, times g of 3, the value of the function g of x function at x equal to 3, plus f of 3 times g prime of 3. Let's calculate f prime of 3 first. So this is x equal to 3. So we have to find out the derivative of this black line, that is f of x at x equal to 3. So we can use the slope formula. So I'm going to consider 2 points like this one and this one. So once again, I'm going to use the rise over run. This is rise is negative 2, and the run is positive 1. So negative 2 over 1, this equals negative 2. So therefore, f prime of 3 is negative 2 times of g of 3. So g of 3 is this point. So this is closer to 1. Maybe we can say that zero point 0.2 units closer to 1. So this is, we can estimate this to be zero point 0.8 plus f of 3 is the value of the function at x equal to 3. Once again, this is this point. So this is 1 and 2. So this is 2 times of g prime of 3 is the slope of the blue line. We already determined the slope of the blue line is negative 3 over 4. So we put this here. Now let's simplify this. So this equals negative 2 times of zero point 0.8, which is negative 1.6. And we can cancel this 4 with 2 as 2 times. So 1 times of negative 3 is negative 3 by 2. So this equals negative 1.6. Negative 3 by 2 is negative 1.5. And when we add these together, we get negative 3.1. This is once again approximate because we have approximated this value. So it's going to be an approximate value. So therefore, we say that h prime of 3, this is estimated to be negative 3.1.